our real numbers. So last year, I know y'all dealt with I. I is the imaginary number. It's the square root of a negative number. We don't deal with that a lot in here. If you were in Cap Algebra 2, you probably went like off on a tangent with exponents and I don't care about that at all. What I do care about are real numbers and specifically rational and irrational numbers. And I'm not really a vocab person, y'all, but there's no other way to describe irrational and rational except by using those words. So here's what a rational number is. And I'm just going to abbreviate. It can be written as a fraction. It can be a fraction. And then an irrational number cannot be a fraction. It goes on forever. It just goes on forever. If it goes on forever, I can't write it as a fraction. So I got some examples down here. The top row is rational. The bottom row is irrational. And again, guys, everything we talk about today has a greater purpose. So I want to remind you, I don't use calculators in here until like November. I know that you are used to having a calculator in your hands. You'll get used to it. Remember, yesterday is you begin to freak out. Don't freak out. You'll adjust. It's just an adjustment. So if you look at this top row, what does that simplify to? It does. Good job. What does that simplify to? Say again? Oh, wow. You gave me the... Yeah, can you simplify the fraction?
2 over 5.
Yeah. Yeah, 2 over 5. Good job. You were giving me those higher level answers. Yes. That's already simplified. All of those are rational numbers. So look, here's why. And I'm never going to ask you to prove it. I'm just showing the definition. So that's 6. Cool. I can write 6 as a fraction. What about this? Is that 6? Yep. I expressed 6 as a fraction. Cool. That is a rational number. 2 over 5. Now, here's what you can't do. You can't write it as a fraction over 1 because you can do that with irrationals also. But I can write 300 over 100. I could write 3 million over 1 million. I just can't use 1 as the denominator. Okay. So cool. All of these are for sure rational. Yes, they are. And then let's talk about the other kind. So again, you cannot use a calculator, bless you, for a while. Let me write some stuff. You don't have to write this. I'm going to erase it. So let's pretend you're taking a test or a quiz, and you're dealing with the square root of 72, and Ms. Harrington's not letting you use a calculator. 72 is fair game. I wouldn't ask you to find the root of like something that's in the thousands on a non-calculator test. But this is fair. This is within reason. So if you know the answer to this, that's cool. Let's pretend I don't know the answer. But I know it's an even number, so I can divide. What can I divide 72 by? Every time you see an even number and you don't know what to do with it, start dividing by 2. So 72 divided by 2. Oh. So 72 is 2 times 36. Awesome. So again, we're going to take this 6 out by the root. Remember, that's a perfect square. We're going to take the root out, which is 6. Nothing times itself makes 2. So 2 is going to stay underneath that square root symbol. So to simplify this, that's it. That's all I can do with that. Now listen, if we did have calculators and if I did put in the square root of 2 and hit enter, it would be like 1.41 something 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 to the end of the screen. But that's because the screen stopped. The screen is finite. That number is going to go on forever. No pattern, nothing repeating. That's why it's impossible to write it as a fraction. So, like if I hit 2 divided by 3 on the calculator, what's the decimal for 2 over 3? Point. Yeah, it repeats. That's a pattern. That's easy to write as a fraction. But not anything that has a pattern is impossible. That's why it's irrational. 37, y'all, 37 is prime. There's no numbers that make 37. So that just stays like that. And guys, y'all know pi goes on forever. Everybody knows that. E is the natural number, and it is irrational also. I'm not talking about E at all this semester. And when I talk about it next semester, it's low level. Just kind of recognize it as another irrational number. So all of these guys are irrational. So know the difference between rational and irrational. Also, just, get in the frame of mind that you're not using a calculator and you're going to be able to handle it. I promise you. Okay. 3 parts in our notes. 1 part down. Next part is called literal equations. Y'all, I wouldn't even write that yet. I'll give you time to write that. So for these literal equations, y'all, the word literal is just a fancy word for no numbers. If you notice, there are not any numbers in this. Okay, here's the reason why I'm bringing this up. We're going to solve for B on both of these. But listen, we do a lot of solving, and they get a little weird. There's 2 rules you need to remember if you get stuck. First of all, you cannot solve if it's in a fraction. So down here, if I'm trying to solve for B, forget it. It's not going to happen. I cannot solve when there's a fraction. Number 2, and really important, the one that most kids forget how to tackle, you cannot solve for a letter if it's written more than 1 time. I don't even care what level math class you're in. You cannot solve for X if it's written more than once. All right, and I'll talk about that later. So I'm going to work these 2 easy problems with you. Then I'm giving you a higher level problem, and I'm going to ask you to do that by yourself in the beginning. All right, so here we go. We are going to solve for B. Okay, I'm just highlighting it so I don't forget because I didn't write down the formal directions. I want B to be all by itself on one side of the equal sign. When you solve equations, you can't solve it when it's in a fraction. You cannot solve it when it's written more than once. When you do not have a fraction and it's only written 1 time, all you do is reverse order of operations. That's all we do. It's still order of operations, we're just doing it in reverse. All right, B is over here on the left side. Do you see any addition or subtraction on the same side as letter B? Yes, you do. See how this Y is being added? Okay, so another point. Do not show unnecessary work that you know in your head. If you know that the plus Y needs to go away and you know immediately it is AB equals CD minus Y, you don't have to write this thing. If I could go in my life without seeing that anymore, I'd be happy. If you need to see that to visualize the next step, go ahead and do it. If you don't need to write that down, you do not need to write down anything extra. I am not requiring a bunch of steps. Trust me, you have no time to show anything that's unnecessary to you. All right, so subtract Y on both sides. Okay, here we go. Nice. All right, we're done with addition and subtraction. I'm trying to solve for B. B is not by itself. Do I have any Division or multiplication, I do. A is being multiplied. You're going to do the opposite. Divide both sides by A. I'll go ahead and show that. So this is going to be B equals CD minus Y over A. Is B by itself? Yes. Is that kind of ugly over there? Yes. But you need to have confidence, like things are not going to be pretty all the time in pre-cal. So this is not required, but it's going to be eventually, so listen up. A can be any number in the universe except 1. What can you not have in the denominator? What number can you never have in the denominator? 0. It is absolutely mathematically untrue and impossible. I'll talk about that later. But just remember, A can never be 0. You cannot have 0 in the denominator. If you did, it would be not defined, but undefined. We use that word a lot. Just a heads up, just a precursor. All right, I'm going to box that in and move on. I've talked about that problem a lot. Let's do another one. Let's be consistent. We'll solve for B again, so I'm going to highlight it. All right, so remember, you cannot solve when it's in a fraction. So let's get rid of the fraction. How do I make that fraction bar go away? Very good, very good. Multiply everything by the denominator. Good job. So look, y'all, I have one term here. This is one fraction. This is one value. This is one value. So one value over here. Cool. One value over here. Awesome. Goodbye fraction. These cancel out these. I'm left with AB. And this is just CXYZ. By the way, these are still just 2 terms on both sides. We're solving for B. We're almost done. We're just going to divide. What are we going to divide by? Very good. We're dividing by A. And again, just a mental note, A cannot equal 0. Your denominator cannot equal 0. All right, next problem. How would I get rid of the fraction? Yeah, let's multiply by C. All right, when I multiply by C, y'all, that just goes away. That C goes away. So it's going to be AX minus BX equals, and y'all don't distribute. Like, I don't even care about this side of the equal sign. But it goes to both of them. It goes to both the D and the H. That's 2 terms over there. It has to go to all of that. So you can distribute if you want. If you don't, that's okay too. But if you don't distribute, you have to put parentheses. It's not CD plus H. You got to make sure it goes to both of them. Okay. I have to, my very next line of my work, I have to write the letter X only one time. Does anybody have an idea how to do that? How could I change the way that looks? Only write the letter X one time. Yeah, it's a GCF. So this is the most common, like, stumped part. And it's just because we don't do it that much. But whenever you guys have written a letter twice, you can factor it out. So this is just going to be A minus B. And now it's smooth sailing. Once you write that letter once, you're good. Now look, this is one term right here. Technically, so is this. If I distribute it, it'd be 2, but we're not distributing. So all I'm going to do, there's no plus or minus right there, which means it's being multiplied. So we're just going to divide. We're going to divide both sides by A minus B. So all of that cancels out all of that because it was multiplied together. And I ran out of room, so I'm just going to put my answer here. So here's my answer. X equals that weird stuff that was already over here on the right side is the numerator, and the denominator is a minus b. And that's it. Are there any